problems. So remember, we're talking about binomial probability, and I told you that this is the toughest stuff that you'll see for the whole year, but get through it. Don't shirk it off as nothing. I don't think it's hard. I will give you the equations. Either they'll be at the top of the test or they will be on the board. So I just have to double check, see how we have it written. I think we had gotten through, we were talking about the basketball problem, and I wish we had page numbers on these, but we don't. But remember we were talking about a basketball player. This is under section 2.4. Basketball player typically makes 82% of his free throws. He shoots 8 times, assuming each throw is independent. Fine. Well, let me go back through and just do A and B so we set the precedent on this. So the success of the free throw throws is 82%. What's the success of not making the free throw? 18. Okay. So the probability of success is 82%, or 0.82, and not good or not whatever is 18%. Okay, so let's go through and see if we can work this out. So the probability makes 5 of the 8 shots. Okay, so we don't know that if you made 1, 2, 3, 4, 5. We don't know if he missed the first and made the next 5 or any combination of that. We just know that 5 out of the 8 shots during the game took place. So I'm going to do the 8 combination 5. And so, and again, this is review. So we have the success of being 0.82, and we're going to raise that to the 5th power, times the probability he did make, which is 0.18. The 2 events have to add up to be 1.0. And then what was I going to raise the 18 to, or the 0.18 to, in order to make this work? 3. So these 2 numbers, you have to make sure they add up to this number here in order for it to work. And if you went through the math, you'd see that it was 0.121 or a 12.1% chance. Back row's talking a little too much. Okay, so not all that good. And then the probability makes 2 of the shots. So then this is 8 combination 2. So I have 0.82 raised to the 2nd, 0.18 raised to the 6th. If you went and did the math out, you'd come up with 0064, or 0064, excuse me. So this is the probability that he makes only 2 of the shots out of 8. I mean, it's pretty low probability. So that would tell you that it might be better to make more of the shots than less of the shots as far as the probability goes. And then letter C, we change things a little bit. It says the probability he misses 6 of the shots. The probability he misses 6 of the shots. It is kind of the same, but we're not going on the success of him making it. We're going on the success of him missing it.
Wouldn't it be the same as that one? Because 6, you miss 6,
Well, let's take a look. Oh, it actually, you're absolutely right. So let's do this. Oh, 6, that's a 6. All right. So, this is going to be the probability he misses it. And we're doing 6 shots, so I'm going to raise that to the 6th power times the probability that he makes it, which is this. And if you look at these 2, the order that we're multiplying in is just backwards. And we know that we can go A times B in math and B times A, and we get the same thing. So this is going to be the same routine as well. Does that make sense? Okay, so now this is one where we want to use our calculator on, because the probability he makes at most 5 of his shots. probability he makes at most 5 shots. So this isn't going to take place as a nice thing. I'm going to use that. It was on the back page. It's called, it's on the calculator. So best place to find this on the calculator, though you can probably find it under the probability modes, is on your calculator. Go to second catalog, beginning that starts with the letter B, find the alpha of B, and then go down to the B, the Bino CDF, and let's figure out what we need to plug in. The probability that he makes at most 5 of his shots. Well, we have 8 shots that we're going to try. That'll be our first number we plug in. We know the probability he makes this is 0.82. And then the last number is, how many shots are we looking at? We're looking at 5. So if you plug that into your calculator, you get what?
Where is that?
So go under catalog. So second of 0. Go down to the B's. So you can either scroll down to the B's or you can hit the alpha B. And I get 8 comma 0.82 comma 5 close parentheses. Yeah, make sure you put the commas in there.
I'm trying to put the alpha while I'm in the catalog and it takes me to tabs.
Okay, so you don't have to hit alpha. It's already in alpha mode when it's in catalog. So if you go second catalog, and then it's the apps key.
Oh, okay, cool. So I
So-
don't need to hit alpha.
Yeah, I'm sorry about that. And then it'll go down to that. And that's kind of a shortcut. Like this one wouldn't have been too long. We only had to go through the A's in order to get there. It's when you have like N's. There's a lot of stuff that this calculator has under its category for you. Okay?
Wait, there's marks now?
What's that?
Yeah, I'm putting in yours. You put comments and multiplication marks?
You just put the commas in. So 8 comma 0.82 comma John's talking comma 5. Quit being Canadian and blaming other people. All right. All right, so the probability he makes at least 3 shots. The probability he makes at least 3 shots. So the probability he makes at least 3 shots. Okay? So how many total shots are being attempted? 8. So I could do the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8. Kind of a lot of work. I mean, because this would be 0.82 times 0.18. This would be a 3 and this would be a 5. And then plus this doing the same thing with 4 and 4, this doing the same thing, so on and so forth. What's another way I can get the answer a little bit shorter? It goes with this a little bit. Oh, not that one. That one. It goes with this. This is the idea here. Kind of goes with that. So let's go back. Any ideas? You're really close. There you go. So if I go 1 minus the probability of 1 plus the probability of 2 plus the probability of 3. That's going to be shorter because I don't have to find all of those probabilities. I just have to find those 3. So I'm doing the complement of what's above. And so, my spot. Oh, and we gotta, actually I'm gonna make that 0, make that 1, make that 2, and make that 3. Okay? And what I can actually do here is I can go 1 minus this. And we're talking about 8 shots, comma, 82% probability of making them, comma, what do I want, 5 there? Oh, I know, I already did. So why do I have a 5 as the last digit? It says probability he makes at least 3 shots. So which way should we do it? Should we plug it into the calculator here? Let's verify that this answer is the same as this answer. God bless you. Probability of 0, so we have 0.82 to the 0 times 0.18. What's that 0.18 going to be raised to? 8. Okay. Plus 0.82 to the first times 0.18 to the 7 plus, am I there yet? So I took care of this one, took care of that one. Let's take care of that one. 0.82 to the second plus, or times, 0.18 to the sixth plus, take care of that one. 0.82 to the third, 0.18 to the fifth. Let's see if we get the same number between the two. Can't see it. 1 minus 0.82 times 0.18 raised to the 8th plus 0.82. Lost my spot. I think I got it. They sure do have a lot of notes that come for you guys. You guys are busy folk. I am off. Anyone get an answer there? Thank you. This gave me 0.839. Did this also give me 0.839? Yep. Okay, sweet. All right, Lauren, where are you at? Not here? Oh, okay. Go tell Sunshine she's not here. All right. Where are we at? Over 3. And then the probability that he makes fewer than 5 of the shots should be the probability 0 plus probability 1, 2, 3, and 4. And so we went through that. So let's go back to that first example about the seeds germinating. It says a biologist is studying a new hybrid of tomato. It is known that the seeds of this hybrid tomato have 70% probability of growing. Biologist plants 10 seeds and finds. Okay, so we have 70% will grow, 30% won't. Okay, so what is the probability that 8 seeds out of the 10 will grow? So this is going to be 10C8, which is going to be 0.7 raised to the 8th power times 0.3 raised to the 2nd power. Where did the 2 come from? Yeah, the 2 that are left over. And do we have an answer? 0.7 raised to the 8th times 0.3 to the 2nd. .45? Don't forget the decimal. It's an important part. It could be. Should be. 0.005?
But that's without. Don't we need to multiply the 10 to the.
What's that?
That's not with 10.
That's minus, yeah, you have to,
Multiply with that.
there's gotta be a 10 below the 7, right?
Do you have to multiply?
Oh, yeah. So,
That's 45. 43 multiplied by 0.0.
43 times that.
Yeah.
So what did we get?
0.22.
0.22. Okay, so 43 is the 10 choose 8 times 0.7 to the 8 times 0.3. Sorry about that. If you multiply them together, so of your 8 seeds where you have a 70% growth rate, having just 8 of those seeds grow is 22%. I don't know.
10 feet is actually 45.
It's 45. Point what? 0.2334. Okay. All right, so we just got it. All right, what about the next one? Probability 5 seeds will germinate. Is it going to be done the same way? So I get 10 choose 5, so somebody figure that out for me. Times 0.7, 0.3. What am I going to raise the 7 to? What am I going to raise the 3 to? 5. What is 10 choose 5? 5? What?
252.
252?
Yes.
Combination order wasn't important, right? Okay. 0.7 to the 5th, 0.3 to the 5th, times 252. 0.102. That's the whole answer.
Just the multiplication is 0.08 or 4.08.
Okay, and then if you multiply that with 252, you get 0.102. Cool. So the probability 5 seeds out of the 10 will germinate is a little bit over 10%. Probability that 8 seeds will germinate is just over 23%. So this is an exact number we're trying to find on these. Then the next one says, at most 3 seeds will germinate. At most 3 seeds will germinate. Okay? At most. So that means we could have 0, we could have 1, 2, and 3. So if I was to write, excuse me, if I write this is going to be 10 choose what? 0. And then the probability of growth, raised to the 0, probability of no growth, 10. How am I going to write this one? 10 choose 1. So 0.7 to the first, 0.3 to the what? Plus 10 choose what? 10 choose 2. 0.7 raised to the second, 0.3 to the eighth. And last one, plus 10 choose 3. 0.7 raised to the third, 0.3 to the seventh. Someone do the red for me, someone do the green, someone do the blue, and someone do the black. Take it out to 4 decimals on each. Shout out if you have an answer for me. And give me a color. Black is 0.009. Okay?
Red is 5.90 times 10 to the negative 6.
10 to the negative 6, so 0.1, 2, 3, 4, 5. What was your number down?
5.9.
5.9. Okay? Green or blue?
Green is 1.377 to the 10 negative 4.
Negative 4. 1, 2, 3. What was your digits?
137.
Okay? And then blue.
Blue is
0.0014. You guys add up the black, the blue, the green, and the red, please. To what?
I got something different.
For blue?
Yeah, I'm not sure if I did it right.
Can we get a third check on blue?
Did you
I know green's red.
Yeah, I did. I got 2.
Green's right?
Yeah, no.
I got 2.43 times 10 to the negative 4.
On blue?
Yeah.
Say it one more time.
2.43 times 10 to the negative 4.
1, 2, 3, 2, 4. 3, you said? Someone verify that?
Add them all up.
Yeah, go ahead and add them up. So add that, strike through that. Got an answer? Go for it.
0.009359.
About that. Supposedly the answer, someone double check.
I got that too.
Okay.
Was it 3859?
I don't know. What?
I just thought I heard an 8 in there.
The 0.009385.
Oh, there was an 8 there. That's okay. So 0.9% chance that at most 3 will grow. That includes 0, 1, 2, and 3. So the higher the probability of success, kind of the lower that you get some of these bad ones. And this is how sometimes in manufacturing they'll have run tests on quality control, and they will take a look at you know, if you were to manufacture, let's go with something like light bulbs. Do you think when light bulbs come off an assembly line that it might go through a quick test of light up or not? I would think, but maybe I'm wrong. But let's say you had like a 99.99% success rate in your light bulbs lighting up. And let's say you're in this factory and you decide you want to save the one step. And you're going to cut out the guy that lights up the light bulbs. Save you $20 an hour. That's $800 a week your factory's saving. 4,000, 40,000 a year. Good enough? So if you have this 99.99% chance that your light bulbs all line up, and then you decide I want to start cutting, I'm not going to change anything else in my manufacturing line. I'm just going to shortcut that all of my lights come on, and I have good data to show that my manufacturing processes have a good thing. There will get, as far as your quality control goes, one, your company's going to save money. If a consumer continues to buy your light bulbs in packs of 20 or whatever you buy your light bulbs in, light bulbs kind of last a long time. You agree? So are you, the consumer, going to be frustrated if you pull one of the light bulbs out of your pack of 20 and one of them doesn't work? Probably not. But still, you know, should have the 20 out of 20 that work. If you had 99.99% chance of 0.949s in a row, probability of it working, your company probably would save good money, and you're not going to get someone who says, you know, I'm going to go from having company A's light bulbs to company B's because one of my light bulbs didn't work out of the 20. And then your neighbor next door had all 20 work. So that might be a way that a company might think about saving money. If you had a large amount of going, we notice this is taking place, this is a redundant position in our company, we're going to take the shot that, you know, we don't need to test these any longer because we know they work with a high-end efficiency. Good or bad? Well, the bad thing is somebody's out of a job. The good thing is maybe the savings would get passed on to you all as consumers. All right. Letter D, at most 8 seeds will germinate. So probability at most 8 grow. Probability at most 8 will grow. Should I go the probability of 1 plus probability of 2, 3, 4, 5, 6, 7, 8? What is the shorter way? 1 minus what? Yeah, so rather than going probability of 0 plus all the way up to the probability of 8, we're going to go 1 minus the probability of 9 plus the probability of 10. That should be a shorter process for us, doing the complement of it. So we're going to go 1 minus, I'm going to put this kind of in bracket. What's this one going to be? 10 choose 9? Times what? Probability that will grow, which is 0.7 raised to what power? The 9th power. Times the probability it won't grow, 0.3 raised to the what power? First. Okay. And then I'm going to add that to 10 choose 10. 0.7 raised to the 10th. 0.3 raised to the 0. A number raised to the 0 power is equal to 1. Okay. Help me out. So I know I have this 1 here. Someone give me an answer for that. God bless you. Someone give me an answer for that one.
For the first part, I got 0.1211.
1211. Okay. Plus.
For the second part, I got 0.0282.
0.0282. All right. Someone do the math. All the math. The whole thing. What's the answer? Say it one more time. 0.1482. Verify or no? Yeah, 1 minus that. Oh, was it 1 minus? Oh, so you did the 0.4282 was the.
Minus that is 0.85.
What was it?
0.85.
0.85? So at most 8 will grow. So the probability of 1, 2, 3, 4, 5, 6, 7, 8 will grow. You have an 85% chance that 2 of them aren't going to grow.
I'm confused because in the ones that it said for the basketball one, like at most, and then when these ones are at most, we do two different things. When do you know when you do one thing and when do you do another?
Okay. So if you know you have a huge string of events you're going to go, like if you had 15 events that were to take place, now I wanted to know like at most 13. Rather than going 1, 2, 3, 4, 5, or 0, 1, 2, 3 all the way up to 13, I'm going to go 1 minus the last 2. But what happens when you're right in the middle?
Well, no, I don't understand that, but when in the basketball one it says at most 5 shots, and we use that binom,
At
whatever.
most 5 shots. Okay.
And then on this one it says at most seeds will grow, we use that huge thing.
Oh, I could have went the other way too.
You could have?
Uh-huh.
But then I tried that.
Did-
was wrong. Well, I might have not. I did subtract it by 1, but I still got it.
So at most 8 will grow.
So you could still use that way.
Yeah, if you go 1 minus and you use the. Actually, you'll see this on the second problem. Okay, and then on this one, at least 7 grow. So probability of 7 plus probability 8 plus probability 9 plus probability 10. We can do it the same way. Or I could use the, it says at least 7 will grow. So if x is less than or equal to r, so that's where you're getting your at least. I can do this. Okay, so if we have the at least 7 will grow, I have the CDF of this, I'm going to go 10. The probability there's a growth is 70%, right? And then at least 7. And then so find the binom CDF. And then go 10, comma 0.7, comma 7. Okay, I bet you just have a Get an answer?
0.6172.
0.6172. Go 1 minus that.
0.38.
And yet you did the CDF.
Yep.
Go 1 minus that. Did my math wrong? Well, sniff of glue while I did it, so. I'm sorry, it's just a habit I haven't been able to kick these days. 10, comma, 0.7, comma, 7. Oh, you got it. Yeah. You guys are right. So, about 0.38. Cool. All right, I think I'm done with those notes. So guys and girls, let's have you guys work on the worksheet 2.4. This is my goal for, so worksheet 2.4. And then tomorrow, which is Tuesday, we have the last portion of the lecture, I think. So I'm going crazy, which is very possible. Geometric probability 2.5. Cool. And then Wednesday will be a review day. And then Thursday will be the test. Sound okay? So this will be 2.5. So, let me ask you all this. Do you all understand the whole concept of